Hey, what's up everyone? Today's video is about gears, motion constraints, and drive constraints. Gears are very important to us. They are used just about everywhere in engineering, and lucky for us, Inventor has this nice gear generator, which means we don't have to design any complex geometry ourselves. So to demonstrate, you can go into any assembly, you can go into the Design tab and click Spur Gear. And once inside the gear generation dialog, you'll see a lot of options. The most critical of these is at the top, which is your design guide. You want to select your design guide based on what parameter of the gear you want to be inferred. The easiest thing to start with would be the center distance, as it already has. Once you have selected your design guide, the next step is to define the universal properties of the gears that you want. Diametral pitch, or DP, defines how many teeth will be fit into 1 radial inch. Pressure angle over here is the angle between the normal line of one gear's tooth to the tangent line of the other gear's pitch circle, which is pretty hard to wrap your mind around from a verbal description, so I'm just going to show you. That is the pressure angle right here. And back here, I'm just going to set that at 14.5 and have the diametral pitch at 20. This total unit correction thing is something you can leave alone when you're starting out. I'm not entirely sure what it does myself. But that's basically the universal properties of the gears, and once you have those done, you can look at the properties of the individual gears. So if we're just making gears in open space like we are doing now, we're going to need to define the number of teeth for each gear. So I'll leave the first gear at 23 teeth and change the second gear to 37 teeth and hit calculate. And you can see that the desired gear ratio has updated automatically, as well as the center distance as per our design guide. And next we can determine face width, which is basically just a measure of how thick we want our gears to be. So I'll make both of these 3/8 of an inch, 0.375 and 0.375. And these are just the essential parameters of the gears. You can play with the others as you need to. Okay, so now that we have all of the essential parameters of the gears defined, we can click OK, hit accept, and there we go. Inventor has just created our gears for us. And now there are some important things to note here. First of all, both gears are created under the same component here, so they will only be able to move independently of each other if you enable flexibility. This means that the distance between the gears is fixed, and we cannot change this. It also means that the gears have motion constraints on them, so they will spin relative to one another correctly. Some of these constraints are good, but some are not. What I usually want is the most control I can possibly get with these gears. So what I'm going to do is I'm going to open each of these gears separately. And save them as separate parts in a known location. Okay. Open this. Save as. And this technique provides a double benefit. From this, I have complete control over the gears individually, which comes in handy when adding things like backlash. It also helps if I ever need these same gears again, I can just go to the known location and grab them instead of repeating the gear generation process multiple times. So now when you bring gears into an assembly, you're usually going to want to need a plate to constrain them to. The plate just contains the center holes where the gears will be located. The best way to find the center distances for the gears is by using the pitch diameter. Basically what pitch diameter is when two gears are meshing correctly, their pitch diameters will be tangent. You'll see this in a little bit. Pitch diameters are automatically created by the gear generator. You can find the dimension using the corresponding sketch. So we can see here that our big gear has a pitch diameter of 1.85 inches, and our small gear has a pitch diameter of 1.15 inches. So using that information, I'm going to create a new part. It's going to be just a plate. Dimensions can be, let's see, 2 inches by 4 inches. Extruded at, say, 1/8 of an inch. And now is where we put our pitch diameters in. So I'll make one circle at 1.85 inches and the other one at 1.15 inches. Now, when the gears are meshing properly, these will be tangent. And that means that the distance between these two centers is always going to be fixed. And actually, while I'm here, I'll add some backlash to these gears. Backlash is just some clearance space between the teeth, which is referenced from the pitch diameter. So I'm going to change these diameters and add an extra 0.02 of an inch. So now that our center distance is defined, all that's left to do is find the locations for the holes on the plate. For simplicity reasons, I'm just going to choose the exact middle. So I'll make that horizontal, put it in the middle there, put that in the middle there. So now that we have our locations, all that's left to do is make the holes. Need a hole there and a hole there. So now if we place our components in an assembly here, we can take the plate and constrain the gears to it. So first thing to do is constrain the center axes to the holes. And then mate the faces of the gear with the face of the plate. And the final thing to do would be to add some motion constraints to these gears. I mentioned this a while back. To do motion constraints, you go into the constrain, you go into the motion tab, and since these gears are going to be spinning opposite direction, you click reverse. And now for these gears, we'll need to spin them at a ratio, and the ratio is simply just a ratio of their teeth. So we have a ratio of 23 to 37. And then select the gears you want to spin. Inventor is usually smart enough to know which is bigger, but I usually just go in the order I see up here. So the 23 goes first, and then the 32nd goes after. Hit OK here. And now we can see that the gears, they'll spin nicely. And the last thing I wanted to touch on here is driving constraints. When you drive constraints, you basically put those constraints into animation. You can only drive mate, flush, and angle constraints, so I'll add an angle constraint here. Mate this plane with this plane. Apply. So now to drive a constraint, you basically have to find it in the browser, right-click, and hit drive. And so basically from here, this box pops up. From here you can determine the start and stop point where you want the constraint to go through. So for example, if I wanted this gear to go through 1 revolution, I can set the start angle at 0 and the end angle at 360 degrees. And I click play. And now you can see that the the entire assembly will rotate based on that one constraint. This is all very useful. You can also determine how fast you want the motion to proceed by changing this value here. You could also enable collision detection if you wanted to. So just as a word of caution to you, gear transmissions can get rough. Right here we have an example of a multiple stage gearbox. You can see how it moves there, and you can also see how the plate here is pretty messy looking. But yeah. So that's about it for now. Until next time, this newly learned info should be sufficient to entertain yourself for the time being. So I'm out. I'll see you later.